All right, it is day 11 of distance learning and we are on to a new topic. So it builds off of the old topic we were looking at, which was graphing linear equations, but now we are going to be graphing linear inequalities. So a lot of the same thing is going to be true, but instead of seeing that equal sign, we're going to see any of these four inequality symbols. So a very quick refresh before we start filling in the notes together. There are four inequality symbols that we've already looked at so far this year. We were graphing one variable inequalities on a number line. We were determining if they were going to be shaded, a shaded dot or an open point, or if we were going to be shading left or right depending on whether it was greater than or less than. So for inequalities, there's not just one solution or just a solution that lie on the line. It could be any ordered pair that makes sense or makes that inequality true. So the four inequality symbols that we have already looked at this year, a very quick refresh. This first one, if it's open like this, it's like eating the number on the left hand side. You know, I don't love that, but it's just one way we look at it. That would be greater than. Whereas the one that looks very similar, but it's in the opposite direction, that would be less than. And then these two fancy ones, they're similar, except they have that extra line underneath it. That's half of an equal sign, which means this symbol is greater than or equal to. And this last one, again, a combination of the less than symbol and an equal sign would be less than or equal to. So a very quick refresh, if you need to hit pause on this video and then write down those four inequality symbols and their meaning, I would do that now. So this was the exact same example that we had on our last video. If you haven't checked it out, go check out day 10's video where we were graphing equations. The same thing is going to be true. The M is still going to represent the slope. The B will represent your y-intercept. You're still going to start by plotting your point on your y-intercept right on your y-axis and then finding your slope by counting your rise and your run. Except instead of having the equals to sign here, it's going to contain any one of these four inequality symbols. So if I were to graph this equation, which again was the last example we did in video number 10, if I change this to, let's say, greater than, you're still going to follow the same process. We're going to start at the y-intercept of 0, 6, and then we're going to be counting our points using our slope. In this case, it was down 2 and to the right 3. But the line itself is going to change, and where we shade on our coordinate plane is going to change. So I'm going to meet you over with our notes. So if you have not yet done so, again, you can hit pause and print out, or at least copy down these three examples that I have at the attached to this Google assignment. Okay, so I'll see you in a second. All right, so we're just picking up right where we left off in our last conversation. And in this case, I have the notes printed in front of me. If you don't have access to a printer, I would make sure that you copy down at least these four new steps. So we already took notes on graphing equations where we start at the y-intercept of 0, b, whatever that number is, that value right here. And then we're finding the next couple of points by following the slope, which would be your rise over your run, whatever value is in for m. When we're graphing a line, we would just connect the points and then we were done. We created a line. However, in an inequality, you're representing all of the numbers for the solution that are greater than or less than that line. So we have to look at two other things before we complete that graph. So if you notice here, when it says to graph inequalities, your first two steps are exactly the same. You're still going to start at your y-intercept, and then you're going to find your next points by following the slope, your rise over your run. However, instead of just connecting the points, we have two different types of lines that we could be creating. We can either be creating a solid line or a dashed line. So a solid line, when I say solid, that's like the line that we use to connect our points. All of your points would be connected. So in this case, it's representing this blue. And that happens when your inequality is equal to. So that means it works for greater than or equal to or less than or equal to. And that means that number that's right on the line makes your inequality true. The other option is that you can have a dashed line. So when I say dashed line, the numbers that are existing right on the line itself don't actually make the inequality true. For example, 4 is not less than 4. So while that's our starting value, it's all the numbers that are less than 4 that work, not that 4 itself. So to show that, we're going to use this dashed line. It's almost like the dotted line if you were picking up your pencil every other time that you're touching it. And so that works when your symbols are greater than or less than. So once you figure out where all your points are on your coordinate plane, you have to determine if it's going to be a solid line or a dashed line. The second thing you need to worry about is whether you're going to be shading above your line or below your line. And so when I say you're shading above your line, that's when all of the numbers are greater than or equal to. If your symbol says less than or equal to, you'll be shading below your line. So those are the notes. We are going to look at 3 examples together. I'm going to try to make this fit. So you can actually determine a lot about a graph before you actually create it. So if you notice here, I have y is greater than 3x minus 1. So before I do any extra work, I can tell right off the bat what my m, my slope is, and what my y-intercept is, my b. Again, m is that number right next to x, so my m would be 3. But don't forget, slope should be the ratio, right, of the rise over the run, and 3 written as a whole, 3 the whole number written as a fraction would be 3 over 1. So I know the slope of this line is 3 over 1. I also know the y-intercept is -1. So I know where I'm starting and how I'm moving. Now I need to determine if I'm going to be shading, if I'm going to be creating a solid or dashed line, or if I'm going to be shading above or below. So again, without actually graphing anything, I'm going to look at this symbol. It's greater than. Greater than matches this symbol right here, which means it's going to be a dashed symbol. So my type of line is going to be dashed. And then I'm going to look at whether I'm shading above or below. Again, this is greater than. So if I look at my greater than symbol, that's in pink, I will be shading above my line. So now that I have that information, I can create my graph. Again, I'm going to start at my y-intercept of -1. So on my y-axis, I'm going to put my first point at -1. And then I'm going to follow my slope. Rise 3, run 1. Up 3 to the right 1. Up 3, 1, 2, 3, and right 1. And again, I'm going to continue that until I run out of room. Once I run out of room, I'm going to go in the opposite direction. Down 3, left 1. So now I'm done putting all of the points that fit on my coordinate plane. Now I'm going to follow the rules that I've already put in place. I know that I'm going to be using a dashed line to connect these points. So I'm going to pick up my pencil every now and again to show that that is in fact a dashed line. And then I've determined that I'm going to be shading above this line. So this gets a little bit tricky, but you're going to look at your y-intercept, which was -1. The numbers that are bigger than -1 are, for example, 2, 3, 4, 5. That would be the side that's above your line. So we have just graphed the inequality y is greater than 3x minus 1 on our coordinate plane. We're going to do the second example together. And again, before I do any graphing, I can determine some information about it. So y is less than or equal to -3 over 2x plus 4. My slope is -3 over 2. That's the number next to x. My y-intercept is 0, 4, or in my case, 4. Now to determine if it's going to be a solid or dashed line, I'm going to look at this symbol. It's less than or equal to, which matches the symbol right here, which means my line is going to be solid. And then again, I look at this symbol, it says less than or equal to, and less than matches shading below. So let's create our graph. We'll use this as an example. So I know that my y-intercept is 4, so on my y-axis, I'm going to start with my point 0, 4. And this time my slope is negative, so my line should be heading downhill. So that means I'm going to be counting down 3, over to the right 2. And I'm going to continue that pattern until I run out of room. Down 3, right 2, and I've run out of room going to the down and to the right. Now I have to go up and to the left. So now we're going to be going up 3 and over to the left 2. And this is the most important, to extend your line all the way across your coordinate plane. Otherwise it makes shading more difficult. So now that I have all of my points on my coordinate plane, I know it's going to be a solid line. So I'm going to play connect the dots like I did with my equations last time. And then I know I'm shading below my line. So if I look at my y-intercept of 4, numbers that are smaller than 4, for example, are 2, 1, 0, all the negative numbers. So I will be shading below this line. We have one more example to take a look at. We have y is less than 1/3 x. And don't forget, if you don't see that y-intercept, that's like adding in plus 0. So my slope is 1/3. My y-intercept is 0. The type of line I'm going to be creating, I look at the symbol, it's less than. Less than will be a dashed line because those numbers are not included. And then again, it's less than, so I will be shading below that line. All the numbers smaller than that will work. Let's create the graph. My y-intercept this time is at the point 0, 0, which is right at the origin. My slope is 1/3, which means I'm going up 1 to the right 3, up 1 to the right 3, and I've run out of room going up and to the right, so I'll go the opposite way. Down 1 and to the left 3, down 1 and to the left 3, and I've run out of room. I'm going to be creating a dashed line because it's not equal to. And so my solution does not exist on the actual line itself. And then I'm going to be shading below because all the numbers less than that make that inequality true. So any number less than 0 has to be negative. Here's where all your negative numbers are on your y-axis. So you'll be shading below your equation, your inequality. So you're going to have a practice, that's a worksheet today. And then again, we're going to continue with this practice on the next class, which will be day 12. That will be a quizzes practice. So we're going to keep practicing graphing. If you have any questions, please reach out to me. You should have these notes written down somewhere so that when you're doing your practice, you have these examples to look at as well. And you have this almost cheat sheet to look at while you're working. All right, so send me an email, guys, if you have any questions. Otherwise, I'll see you soon.